In this example, what we're going to be doing is learning how to identify nodes, and then we're going to see how can we identify elements that are in series and elements that are in parallel. We have a circuit there. We see it has 1, 2, 3, 4 loops, and the way to identify nodes is by remembering at all times, okay, the definition of the node. And a node for us is going to be an electrical connection point that connects several elements. Okay, so it's an electrical connection point that connects several elements. So let's go, and I'm gonna do it with different colors. So you see here that this wire is really connecting this resistor with this voltage source, but it is also connecting this other resistor. So this will be one node. We can call it right now node 1. And we consider this, even though you see like different branches, you see 3 branches there, for our purposes this is really a point, okay? When I say a point, I mean that all the node has exactly the same voltage. If you wire there a voltmeter and you measure the voltage of that point with reference to something else, you're going to see that any point here in the red area has the same voltage. So this is a node, okay? It's an electrical point, even though you see 3 branches, okay? But where you can see all the connections with the different resistors and voltage source. Let's go and find another one. Well, do you agree that this is going to be another node? This is another node because it's another electrical point that is connecting this source with this resistor. So I'm going to call this 2. Let's go now and find another one. You see here, this is another node. All of this is another node because it's connecting, okay, it's an electrical point that is connecting all these elements, the resistor of 25, 45, and 10. Can we identify another node? Yes, there is another one here. Look, all these branches, okay, they are part of the same node. So it's the same electrical point. This is going to be number 4, and I forgot here this is going to be node 3. This is arbitrary, okay, these numbers. I'm just assigning numbers. You can change the order. Do you see another node? Well, here we have another node, okay, because this is connecting these 2 elements. This could be node 5. And we have another one. Yes, there is another one, and is this one. So this is node. We can call it node number 6. So these are all the nodes in the circuit. Now, if the question now is, what are the elements that are in series? Well, elements are going to be in series if they share one terminal, okay, and there is no incoming current, okay, or incoming or outgoing, okay, so there is no current entering or exiting through that terminal that they have in common. So let me just try to show you. Imagine that this is one element and this is another element. So these are going to be in series, okay, because they are sharing one terminal. This is the terminal that they are sharing. Plus, there is no current coming here or exiting here. And so that means there is no other branches, okay, here. So if I say, let me give you another example. In this case, okay, this is not in series because you have this connection. Actually, let me just do it here in red. So this won't be okay. This is not gonna be in series because you have this branch and there might be current coming or exiting through that branch. So having said that, we can see that this element and this element, they share one terminal here, this terminal and this terminal of the resistors. Okay, so they and then there is no other branch there. So basically we're gonna say in series we have the 10 ohm and the 20 ohm. Can we identify any other? You see, just to give you an example, these two, this and this are not in series because this branch is going is there in between, and the same is true for any other resistor here. This one, for example, is not in series with this one. Why? Because you have this branch there. If this branch didn't exist, this one, okay, then these two will be in series, but that is not the case. However, here you see this element and this element, they are in series because they share here the terminals, and there is no any branch here. So I'm gonna say the 12 volt and the 25 ohm. And what is the meaning? What do we mean when we say that they are in series? Basically, or what is a feature, more characteristic of elements in series, is that they share, okay, the same current. They have the same current. The current is the same in all elements in series. Elements in series. You can explore the rest of the circuit. There are no other elements in series. Now, how about parallel? Parallel are gonna be elements that they share, okay, the two terminals. So the two terminals of the elements are connected together. So if you have one element like this and another element like this, and they are connected here and they are connected here, they are in parallel. Sometimes, they are appear like this. Okay, this is in parallel too, okay, because this terminal is connected to this and this terminal is connected to this. So this is what we have, these are elements in parallel. So do we have something in parallel? Well, actually no. Okay, we can see that nothing is in parallel. This is not parallel to this because you have the resistor in between, so these are not parallel. This is not in parallel with this because you have this resistor in between. So really, if you examine this circuit, okay, in parallel, I'm gonna say none. Okay, so there is no elements in parallel in this circuit.